This is a photo of a pile of grocery store receipts. The items and prices are blurred. Figure 11. 1. The chi-square distribution can be used to find relationships between two things, like grocery prices at different stores. Credit, modification of work. The first few times I used my Asda bag for life, I left the receipts in the bottom of the bag by Pete Flicker. Public domain, chapter objectives. By the end of this chapter, the student should be able to interpret the chi-square probability distribution as the sample size changes. Conduct and interpret chi-square goodness of fit hypothesis tests. Conduct and interpret chi-square test of independence hypothesis tests. Conduct and interpret chi-square homogeneity hypothesis tests. Conduct and interpret chi-square single variance hypothesis tests. Have you ever wondered if lottery numbers were evenly distributed, or if some numbers occurred with a greater frequency? How about if the types of movies people preferred were different across different age groups? What about if a coffee machine was dispensing approximately the same amount of coffee each time? You could answer these questions by conducting a hypothesis test. You will now study a new distribution, one that is used to determine the answers to such questions. This distribution is called the chi-square distribution. In this chapter, you will learn the three major applications of the chi-square distribution. The goodness of fit test, which determines if data fit a particular distribution, such as in the lottery example the test of independence, which determines if events are independent, such as in the movie example the test of a single variance, which tests variability, such as in the coffee example. Note, though the chi-square distribution depends on calculators or computers for most of the calculations, there is a table available. See Appendix G notes for the T83, 83 plus 84, 84 plus calculators. T83 plus and T84 calculator instructions are included in the text. Collaborative exercise: look in the sports section of a newspaper or on the internet for some sports data. Baseball averages, basketball scores, golf tournament scores, football odds, swimming times, and the like. Plot a histogram and a box plot using your data. See if you can determine a probability distribution that your data fits. Have a discussion with the class about your choice. The notation for the chi-square distribution is letter 1 D712, letter 1 D712, letter 1 D451, letter 1 D453, where df equals degrees of freedom, which depends on how chi-square is being used. If you want to practice calculating chi-square probabilities, then use df equals n1. The degrees of freedom for the three major uses are each calculated differently. For the chi-2 distribution, the population mean is mu equals df, and the population standard deviation is letter 1 D70 equals 2 letter 1 D451 letter 1 D453 square. The random variable is shown as chi2, but may be any uppercase letter. The random variable for a chi-square distribution with k degrees of freedom is the sum of k independent squared standard normal variables. Chi2 equals z1 2 plus z2 2 plus zk2. The curve is non-symmetrical and skewed to the right. There is a different chi-square curve for each df. Part A shows a chi-square curve with 2 degrees of freedom. It is non-symmetrical and slopes downward continually. Part B shows a chi-square curve with 24 df. This non-symmetrical curve does have a peak and is skewed to the right. The graphs illustrate that different degrees of freedom produce different chi-square curves. Figure 11. 2. The test statistic for any test is always greater than or equal to 0. When df 90, the chi-square curve approximates the normal distribution. For x letter 1 D71221, 0, 0, 0, the mean, mu equals df equals 1000 and the standard deviation, sigma equals 2, 1, 0, 0, 0, square equals 44. 7. Therefore, x tilde n, 1, 0, 0, 0, 44, 7, approximately. The mean mu is located just to the right of the peak. This is a non-symmetrical chi-square curve which is skewed to the right. The mean, m, is labeled on the horizontal axis and is located to the right of the curve's peak. Figure 11. 3. In this type of hypothesis test, you determine whether the data fit a particular distribution or not. For example, you may suspect your unknown data fit a binomial distribution. You use a chi-square test, meaning the distribution for the hypothesis test is chi-square, to determine if there is a fit or not. The null and the alternative hypotheses for this test may be written in sentences or may be stated as equations or inequalities. The test statistic for a goodness of fit test is letter 1d6f4 letter 1d458, letter 1d442 minus letter 1d4382, letter 1d438 where O equals observed values, data, E equals expected values from theory, K equals the number of different data cells or categories, the observed values are the data values, and the expected values are the values you would expect to get if the null hypothesis were true. There are n terms of the form, letter 1d442 minus letter 1d4382 letter 1d438. The number of degrees of freedom is df equals number of categories, 1. The goodness of fit test is almost always right-tailed. If the observed values and the corresponding expected values are not close to each other, then the test statistic can get very large and will be way out in the right tail of the chi-square curve. Note the expected value for each cell needs to be at least 5 in order for you to use this test. Example 11. 1. Absenteeism of college students from math classes is a major concern to math instructors because missing class appears to increase the drop rate. Suppose that a study was done to determine if the actual student absenteeism rate follows faculty perception. The faculty expected that a group of 100 students would miss class according to Table 11. 1. Number of absences per term, expected number of students, 0, 253, 536, 8, 12, 9, 11, 6, 12, plus 2 Table 11. 1. A random survey across all mathematics courses was then done to determine the actual number observed of absences in a course. The chart in Table 11. 2 displays the results of that survey. Number of absences per term, actual number of students, 0, 235, 35, 46, 829, 11, 112 plus 4 Table 11. To determine the null and alternative hypotheses needed to conduct a goodness of fit test. H0. Student absenteeism fits faculty perception. The alternative hypothesis is the opposite of the null hypothesis. Student absenteeism does not fit faculty perception. Problem A. Can you use the information as it appears in the charts to conduct the goodness of fit test? Solution A. No. Notice that the expected number of absences for the 12 plus entry is less than 5. It is 2. Combine that group with the 9-11 group to create new tables where the number of students for each entry are at least 5. The new results are in Table 11. 3 and Table 11. 4. Number of absences per term, expected number of students, 0, 253, 536, 812, 9 plus 8 Table 11. 3. Number of absences per term, actual number of students, 0, 235, 3546, 829 plus 5 Table 11. 4. Problem B. What is the number of degrees of freedom, df? Solution B. There are 4 cells or categories in each of the new tables. df equals number of cells, 1 equals 4, 1 equals 3, try it 11. 1. A factory manager needs to understand how many products are defective versus how many are produced. The number of expected defects is listed in Table 11. 5. Number produced, number defective, 0, 105, 101, 206, 201, 307, 301, 408, 401, 510, Table 11. 5. A random sample was taken to determine the actual number of defects. Table 11. 6 shows the results of the survey. Number produced, number defective, 0, 105, 101, 207, 201, 308, 301, 409, 401, 511, Table 11. 6. State the null and alternative hypotheses needed to conduct a goodness of fit test, and state the degrees of freedom. Example 11. Two problem employers want to know which days of the week employees are absent in a 5-day work week. Most employers would like to believe that employees are absent equally during the week. Suppose a random sample of 60 managers were asked on which day of the week they had the highest number of employee absences. The results were distributed as in Table 11. 7. For the population of employees, do the days for the highest number of absences occur with equal frequencies during a 5-day work week? Test at a 5% significance level. Monday, Tuesday, Wednesday, Thursday, Friday number of absences, 15, 12, 9, 9, 15, Table 11. 7-day of the week employees were most absent. Solution. The null and alternative hypotheses are H0. The absent days occur with equal frequencies, that is, they fit a uniform distribution. The absent days occur with unequal frequencies, that is, they do not fit a uniform distribution. If the absent days occur with equal frequencies, then, out of 60 absent days, the total in the sample, 15 plus 12 plus 9 plus 9 plus 15 equals 60. There would be 12 absences on Monday, 12 on Tuesday, 12 on Wednesday, 12 on Thursday, and 12 on Friday. These numbers are the expected E values. The values in the table are the observed O values or data. This time, calculate the Chi-2 test statistic by hand. Make a chart with the following headings and fill in the columns. Expected E values 12, 12, 12, 12, 12. Observed O values 15, 12, 9, 9, 15. OE. OE2. O letter 1 D438 2 letter 1 D438. Now add sum the last column. The sum is 3. This is the Chi-2 test statistic. To find the p-value, calculate p Chi-2 3. This test is right-tailed. Use a computer or calculator to find the p-value. You should get p-value equals 0. 5578. The DFS are the number of cells. 1 equals 5, 1 equals 4 using the T83, 83 plus 84, 84 plus calculator. Press second DISTR. Arrow down to Chi to CDF. Press Enter. Enter 3 1099 4. Rounded to 4 decimal places, you should see 0. 5578, which is the p-value. Next, complete a graph like the following one with the proper labeling and shading. You should shade the right tail. This is a blank non-symmetrical chi-square curve for the test statistic of the days of the week absent. Figure 11. 4. The decision is not to reject the null hypothesis. Conclusion. At a 5% level of significance from the sample data, there is not sufficient evidence to conclude that the absent days do not occur with equal frequencies. Using the T83, 83 plus 84, 84 plus calculator T83 plus, and some T84 calculators, do not have a special program for the test statistic for the goodness of fit test. The next example, example 11. 3 has the calculator instructions. The newer T84 calculators have in stat tests the test Chi2 GOF. To run the test, put the observed values, the data, into a first list and the expected values, the values you expect if the null hypothesis is true, into a second list. Press stat tests and Chi2 GOF. Enter the list names for the observed list and the expected list. Enter the degrees of freedom and press calculate or draw. Make sure you clear any lists before you start. To clear lists in the calculators, go into Stat Edit and arrow up to the list name area of the particular list. Press clear and then arrow down. The list will be cleared. Alternatively, you can press Stat and press 4 for CLR list. Enter the list name and press Enter. Try it 11. 2 teachers want to know which night each week their students are doing most of their homework. Most teachers think that students do homework equally throughout the week. Suppose a random sample of 56 students were asked on which night of the week they did the most homework. The results were distributed as in Table 11. 8. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Number of students 11, 8, 10, 7, 10, 5, 5. Table 11. 8 from the population of students. Do the nights for the highest number of students doing the majority of their homework occur with equal frequencies during a week? What type of hypothesis test should you use? Example 11. 3. One study indicates that the number of streaming services that American families have is distributed. This is the given distribution for the American population, as in Table 11. 9. Number of streaming services percent 0, 10, 1, 16, 2, 55, 3, 11, 4 plus 8. Table 11. 9. The table contains expected %. A random sample of 600 families in the far western United States resulted in the data in Table 11. 10. Number of streaming services frequency 0, 66, 1, 119, 2, 343, 64, plus 15 total equals 600. Table 11. 10. The table contains observed O frequency values. Problem at the 1% significance level. Does it appear that the distribution number of streaming services of far western United States families is different from the distribution for the American population as a whole? Solution: this problem asks you to test whether the far western United States families distribution fits the distribution of the American families. This test is always right-tailed. The first table contains expected percentages. To get expected frequencies, multiply the percentage by 600. The expected frequencies are shown in Table 11. 11. Number of streaming services percent expected frequency 0, 10, 0. 10, 600 equals 61, 16, 0. 16, 600 equals 96, 255, 0. 55, 600 equals 333, 11, 0. 11, 600 equals 66 over 380. 08, 600 equals 48. Table 11. 11. Therefore, the expected frequencies are 60, 96, 330, 66, and 48. In the T calculators, you can let the calculator do the math. For example, instead of 60, enter 0. 10 asterisk 600. H0. The number of streaming services, distribution of far western United States families is the same as the number of streaming services, distribution of the American population. The number of streaming services, distribution of far western United States families is different from the number of streaming services, distribution of the American population. Distribution for the test. Letter 1 D71224, where DF equals the number of cells. 1 equals 5, 1 equals 4. Note DF not equal to 601. Calculate the test statistic. Chi 2 equals 29. 65 graph. This is a non-symmetric chi-square curve with values of 0, 4, and 29. 65 labeled on the horizontal axis. The value 4 coincides with the peak of the curve. A vertical upward line extends from 29, 65 to the curve, and the region to the right of this line is shaded. The shaded area is equal to the p-value. Figure 11. 5 probability statement. P-value equals p, chi 2, 29. 65 equals 0. 6 compare alpha and the p-value, alpha equals 0. 1 p-value equals 0. 6 so, alpha p-value. Make a decision. Since alpha p-value, reject HO. This means you reject the belief that the distribution for the far western states is the same as that of the American population as a whole. Conclusion. At the 1% significance level from the data, there is sufficient evidence to conclude that the number of streaming services, distribution for the far western United States, is different from the number of streaming services, distribution for the American population as a whole. Using the T83, 83 plus 84, 84 plus calculator, press Stat and enter. Make sure to clear lists L1, L2, and L3 if they have data in them. See the note at the end of example 11. 2. Into L1, put the observed frequencies 66, 119, 340, 60, 15. Into L2, put the expected frequencies 10 asterisk 600, 16 asterisk 600, 55 asterisk 600, 11 asterisk 600, 08 asterisk 600. Arrow over to list L3 and up to the name area L3. Enter L1 L2 2/L2 and enter. Press second quit. Press second list and arrow over to math. Press 5. You should see sum. Enter L3. Rounded to 2 decimal places you should see 29, 65. Press second DISTR. Press 7 or arrow down to 7. Chai to CDF and press enter. Enter 29, 651 E994. Rounded to 4 places you should see 5. 77 E6 equals 6, rounded to 6 decimal places, which is the p-value. The newer T84 calculators have in stat TESTS the test Chi2 GOF. To run the test, put the observed values, the data, into a first list and the expected values, the values you expect if the null hypothesis is true, into a second list. Press stat tests and Chi2 GOF. Enter the list names for the observed list and the expected list. Enter the degrees of freedom and press calculate or draw. Make sure you clear any lists before you start. Try at 11. 3. The expected percentage of the number of pet students have in their homes is distributed. This is the given distribution for the student population of the United States, as in Table 11. 12. Number of pets percent 0, 18, 1, 25, 2, 33, 18, 4, plus 9 Table 11. 12. A random sample of 1,000 students from the eastern United States resulted in the data in Table 11. 13. Number of pets frequency 0, 210, 1, 242, 323, 144, plus 90 Table 11. 13. At the 1% significance level, does it appear that the distribution, number of pets of students in the eastern United States, is different from the distribution for the United States student population as a whole? What is the p-value? Example 11. For problem, suppose you flip 2 coins 100 times. The results are 20 HH, 27 HT, 30 TH, and 23 TT. Are the coins fair? Test at a 5% significance level. Solution: this problem can be set up as a goodness of fit problem. The sample space for flipping 2 fair coins is HH, HT, TH, TT. Out of 100 flips, you would expect 25 HH, 25 HT, 25 TH, and 25 TT. This is the expected distribution. The question, are the coins fair, is the same as saying, does the distribution of the coins 20 HH, 27 HT, 30 TH, 23 TT fit the expected distribution? Random variable. Let x equals the number of heads in one flip of the 2 coins. X takes on the values 0, 1, 2. There are 0, 1, or 2 heads in the flip of 2 coins. Therefore, the number of cells is 3. Since x equals the number of heads, the observed frequencies are 20 for 2 heads, 57 for 1 head, and 23 for 0 heads or both tails. The expected frequencies are 25 for 2 heads, 50 for 1 head, and 25 for 0 heads or both tails. This test is right-tailed. H0, the coins are fair. The coins are not fair. Distribution for the test. Letter 1 D7 1 2 22, where DF equals 3 1 equals 2. Calculate the test statistic. Chi2 equals 2 14 graph. This is a non-symmetrical chi-square curve with values of 0 and 214 labeled on the horizontal axis. A vertical upward line extends from 214 to the curve, and the region to the right of this line is shaded. The shaded area is equal to the p-value. Figure 11. 6 probability statement. P-value equals P. Chi2 214. equals 0.3430. Compare alpha and the p-value. Alpha equals 0. 5 p-value equals 0.3430. Alpha p-value. Make a decision. Since alpha p-value, do not reject H0. Conclusion. There is insufficient evidence to conclude that the coins are not fair. Using the T83, 83 plus 84, 84 plus calculator, press Stat and enter. Make sure you clear lists L1, L2, and L3 if they have data in them. Into L1, put the observed frequencies 20, 57, 23. Into L2, put the expected frequencies 25, 50, 25. Arrow over to list L3 and up to the name area L3. Enter L1, L2, 2/L2 and enter. Press second quit. Press second list and arrow over to math. Press 5. You should see sum. Enter L3. Rounded to 2 decimal places, you should see 214. Press second DISDR. Arrow down to 7, try to see DF or press 7. Press enter. Enter 2. 141 E992. Rounded to 4 places, you should see 3430, which is the p-value. The newer T84 calculators have in stat TESDS the test Chi2GOF. To run the test, put the observed values, the data, into a first list and the expected values, the values you expect if the null hypothesis is true, into a second list. Press stat tests and Chi2GOF. Enter the list names for the observed list and the expected list. Enter the degrees of freedom and press calculate or draw. Make sure you clear any lists before you start. Try at 11. 4 students in a social studies class hypothesize that the literacy rates across the world for every region are 82%. Table 11. 14 shows the actual literacy rates across the world broken down by region. What are the test statistic and the degrees of freedom? MDG region adult literacy rate, percent, developed regions 99. 0 Commonwealth of Independent States 99. 5 Northern Africa 67. 3 Sub-Saharan Africa 62. 5 Latin America and the Caribbean 91. Eastern Asia 93. 8 Southern Asia 61. 9 Southeastern Asia 91. 9 Western Asia 84. 5 Oceania 66. 4 Table 11, 14. Tests of independence involve using a contingency table of observed data values. The test statistic for a test of independence is similar to that of a goodness of fit test. Letter 1 D6F4, letter 1 D456, letter 1 D457, letter 1 D442, letter 1 D4382, letter 1 D438. Where O equals observed values, E equals expected values, I equals the number of rows in the table, J equals the number of columns in the table. There are letter 1 D456, letter 1 D457. Terms of the form, letter 1 D442, letter 1 D438, letter 1 D438. A test of independence determines whether 2 factors are independent or not. You first encountered the term independence in probability topics. As a review, consider the following example. Note, the expected value for each cell needs to be at least 5 in order for you to use this test. Example 11. 5. Suppose A equals a speeding violation in the last year, and B equals a cell phone user while driving. If A and B are independent, then P, A and B equals P. A, P, B. A and B is the event that a driver received a speeding violation last year and also used a cell phone while driving. Suppose, in a study of drivers who received speeding violations in the last year and who used cell phone while driving, that 755 people were surveyed. Out of the 755, 70 had a speeding violation and 685 did not. 305 used cell phones while driving and 450 did not. Let Y equals expected number of drivers who used a cell phone while driving and received speeding violations. If A and B are independent, then P, A and B equals P, A, P, B. By substitution, Letter 1D466 755 equals 70,755. 305,755. Solve for y. Y equals 70. 305, 755 equals 28. 3. About 28 people from the sample are expected to use cell phones while driving and to receive speeding violations. In a test of independence, we state the null and alternative hypotheses in words. Since the contingency table consists of two factors, the null hypothesis states that the factors are independent, and the alternative hypothesis states that they are not independent, dependent. If we do a test of independence using the example, then the null hypothesis is H0. Being a cell phone user while driving and receiving a speeding violation are independent events. If the null hypothesis were true, we would expect about 28 people to use cell phones while driving and to receive a speeding violation. The test of independence is always right-tailed because of the calculation of the test statistic. If the expected and observed values are not close together, then the test statistic is very large and way out in the right tail of the chi-square curve, as it is in a goodness of fit. The number of degrees of freedom for the test of independence is df equals number of columns 1, number of rows 1. The following formula calculates the expected number E. Letter 1D438 equals row total, column total number surveyed. Try it 11, 5. A sample of 300 students is taken. Of the students surveyed, 50 were music students, while 250 were not. 97 were on the honor roll, while 203 were not. If we assume being a music student and being on the honor roll are independent events, what is the expected number of music students who are also on the honor roll? Example 11, 6. In a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. The program recruits among community college students, four-year college students, and non-students. In Table 11, 15 is a sample of the adult volunteers and the number of hours they volunteer per week. Type of volunteer, 1 3 hours, 4 6 hours, 7 9 hours row total. Community college students, 111 96, 40, 8 255. Four-year college students, 96 133, 61 290. Non-students, 91, 150 53 294. Column total, 298, 379, 162, 839. Table 11. 15 number of hours worked per week by volunteer type, observed. The table contains observed O values data. Problem. Is the number of hours volunteered independent of the type of volunteer? Solution. The observed table and the question at the end of the problem. Is the number of hours volunteered independent of the type of volunteer? Tell you this is a test of independence. The two factors are number of hours volunteered and type of volunteer. This test is always right-tailed. H0, the number of hours volunteered, is independent of the type of volunteer. The number of hours volunteered is dependent on the type of volunteer. The expected results are in Table 11. 16. Type of volunteer 1-3 hours, 4-6 hours, 7-9 hours. Community college students 90. 57 115, 1949, 24. Four-year college students 103, 131, 56. Non-students 104, 42 132, 80 156, 77. Table 11. 16 number of hours worked per week by volunteer type. Expected. The table contains expected E values data. For example, the calculation for the expected frequency for the top left cell is letter 1D438 equals row total, column total number surveyed equals 255, 298, 839 equals 90. 57. Calculate the test statistic. Chi 2 equals 12, 99 calculator or computer. Distribution for the test. Letter 1 D7 1 2 24. DF equals 3 columns 1, 3 rows 1 equals 2, 2 equals 4. Graph. Non-symmetrical chi-square curve with values of 0 and 12. 99 on the x-axis representing the test statistic of number of hours worked by volunteers of different types. A vertical upward line extends from 12.99 to the curve, and the area to the right of this is equal to the p-value. Figure 11.7. Probability statement. P-value equals p chi 2 12. 99 equals 0. 113. Compare alpha and the p-value. Since no alpha is given, assume alpha equals 0. 5. P-value equals 0. 113. Alpha p-value. Make a decision. Since alpha p-value, reject H0. This means that the factors are not independent. Conclusion. At a 5% level of significance from the data, there is sufficient evidence to conclude that the number of hours volunteered and the type of volunteer are dependent on one another. For the example in Table 11.15, if there had been another type of volunteer, teenagers, what would the degrees of freedom be? Using the T83, 83 plus 84, 84 plus calculator. Press the MATRX key and arrow over to edit. Press 1A, press 3, enter 3, enter. Enter the table values by row from Table 11.15. Press enter after each. Press second, quit. Press stat and arrow over to tests. Arrow down to see Chi 2 test. Press enter. You should see observed, A, and expected, B. If necessary, use the arrow keys to move the cursor after observed, and press second MATRX. Press 1A to select matrix A. It is not necessary to enter expected values. The matrix listed after expected can be blank. Arrow down to calculate. Press enter. The test statistic is 12.9909 and the p-value equals 0.113. Do the procedure a second time, but arrow down to draw instead of calculate. Try it 11.6. The Bureau of Labor Statistics gathers data about employment in the United States. A sample is taken to calculate the number of U.S. citizens working in one of several industry sectors over time. Table 11.17 shows the results. Industry sector 2000-2010, 2020 total. Non-agriculture wage and salary 13, 243.13, 044.15, 018.41, 305. Goods producing, excluding agriculture 2, 457.1, 771.1, 956, 178. Services providing 10, 786.11, 273.13, 068.35, 127. Agriculture, forestry, fishing, and hunting 240, 214, 200, 1, 655. Non-agriculture, self-employed and unpaid family worker 930, 1, 894, 972, 2, 797. Secondary wage and salary jobs in agriculture and private household industries 1411, 1136. Secondary jobs as a self-employed or unpaid family worker 196, 140, 4, 152, 492. Total 27, 867, 27, 351, 31, 372, 86, 590. Table 11.17. We want to know if the change in the number of jobs is independent of the change in years. State the null and alternative hypotheses and the degrees of freedom. Example 11.7. De Anza College is interested in the relationship between anxiety level and the need to succeed in school. A random sample of 400 students took a test that measured anxiety level and need to succeed in school. Table 11.18 shows the results. De Anza College wants to know if anxiety level and need to succeed in school are independent events. Need to succeed in school high. Anxiety mid-high. Anxiety medium. Anxiety mid-low. Anxiety low. Anxiety row total. High need 35 42 53, 15 10 155. Medium need 18 48 63 33 30 1 193. Low need 4 5 11 15, 17 52. Column total 57 95 127, 63 58 400. Table 11. 18 need to succeed in school versus anxiety level. Problem A. How many high anxiety level students are expected to have a high need to succeed in school? Solution. The column total for a high anxiety level is 57. The row total for high need to succeed in school is 155. The sample size or total surveyed is 400. Letter 1D438 equals row total. Column total surveyed equals 155 57,400 equals 22. 9. The expected number of students who have a high anxiety level and a high need to succeed in school is about 22. Problem B. If the two variables are independent, how many students do you expect to have a low need to succeed in school and a med-low level of anxiety? Solution. B. The column total for a med-low anxiety level is 63. The row total for a low need to succeed in school is 52. The sample size or total surveyed is 400. Letter 1D438 equals row total, column total surveyed equals 8. 19. The expected number of students who have a low need to succeed in school and a med-low level of anxiety is 8. Try it 11. 7. Refer back to the information in Try it 11. 6. How many service-providing jobs are there expected to be in 2020? How many non-agriculture wage and salary jobs are there expected to be in 2020? The goodness of fit test can be used to decide whether a population fits a given distribution, but it will not suffice to decide whether two populations follow the same unknown distribution. A different test, called the test for homogeneity, can be used to draw a conclusion about whether two populations have the same distribution. To calculate the test statistic for a test for homogeneity, follow the same procedure as with the test of independence. Note, the expected value for each cell needs to be at least 5 in order for you to use this test. Hypotheses. H0, the distributions of the two populations are the same. Ha. The distributions of the two populations are not the same. Test statistic. Use a letter 1D7122. Test statistic. It is computed in the same way as the test for independence. Degrees of freedom df. df equals number of columns 1. Requirements. All values in the table must be greater than or equal to 5. Common uses. Comparing two populations, for example, men versus women before versus after, east versus west. The variable is categorical with more than 2 possible response values. Example 11. 8. Problem. Do men and women college students have the same distribution of living arrangements? Use a level of significance of 0. 5. Suppose that 250 randomly selected men college students and 300 randomly selected women college students were asked about their living arrangements. Dormitory, apartment, with parents, other. The results are shown in Table 11. 19. Do male and female college students have the same distribution of living arrangements? Dormitory, apartment, with parents, other. Men 72, 84, 49, 45. Women 91, 86, 88, 35. Table 11. 19. Distribution of living arrangements for college men and college women. Solution. H0. The distribution of living arrangements for men college students is the same as the distribution of living arrangements for women college students. The distribution of living arrangements for men college students is not the same as the distribution of living arrangements for women college students. Degrees of freedom, df. df equals number of columns, 1 equals 4, 1 equals 3. Distribution for the test, letter 1D71223. Calculate the test statistic, chi 2 equals 10. 1287, calculator or computer. Probability statement, p-value equals p chi 210, 1287 equals 0, 175. Using the T83, 83 plus 84, 84 plus calculator. Press the MATRX key and arrow over to edit. Press 1, A, press 2, enter 4, enter. Enter the table values by row, press enter after each, press second quit, press stat and arrow over to tests. Arrow down to see Chi 2 test, press enter, you should see observed. A and expected, B. Arrow down to calculate, press enter. The test statistic is 10/12/87 and the p-value equals 0, 175. Do the procedure a second time but arrow down to draw instead of calculate. Compare alpha and the p-value. Since no alpha is given, assume alpha equals 0. 5. P-value equals 0, 175. Alpha p-value. Make a decision since alpha p-value reject H0. This means that the distributions are not the same. Conclusion. At a 5% level of significance from the data, there is sufficient evidence to conclude that the distributions of living arrangements for men and women college students are not the same. Notice that the conclusion is only that the distributions are not the same. We cannot use the test for homogeneity to draw any conclusions about how they differ. Try it 11. 8. Do families and singles have the same distribution of cars? Use a level of significance of 0. 5. Suppose that 100 randomly selected families and 200 randomly selected singles were asked what type of car they drove. Sport, sedan, hatchback, truck, van, SUV. The results are shown in Table 11. 20. Do families and singles have the same distribution of cars? Test at a level of significance of 0. 5. Sport, sedan, hatchback, truck, van / SUV. Family 5, 1535, 1728. Single 40, 565, 37, 46, 7. Table 11, 20. Example 11. 9. Problem. Both before and after a recent earthquake, surveys were conducted asking voters which of the 3 candidates they planned on voting for in the upcoming city council election. Has there been a change since the earthquake? Use a level of significance of 0. 5. Table 11. 21 shows the results of the survey. Has there been a change in the distribution of voter preferences since the earthquake? Perez Chung Stevens. Before 167, 128, 135. After 214, 197, 225. Table 11. 21. Solution. H0. The distribution of voter preferences was the same before and after the earthquake. The distribution of voter preferences was not the same before and after the earthquake. Degrees of freedom, DF. DF equals number of columns, 1 equals 3, 1 equals 2. Distribution for the test. Letter 1 D7 1 2 22. Calculate the test statistic. Chi 2 equals 3. 2603. Calculator or computer. Probability statement. P-value equals P Chi 2 32603 equals 0 1959. Using the T83, 83 plus 84, 84 plus calculator. Press the MATRX key and arrow over to edit. Press 1, A, press 2, enter 3, enter. Enter the table values by row, press enter after each, press second quit, press stat and arrow over to tests. Arrow down to see Chi 2 test, press enter, you should see observed. A and expected, B. Arrow down to calculate, press enter. The test statistic is 32603 and the p-value equals 0 1959. Do the procedure a second time but arrow down to draw instead of calculate. Compare alpha and the p-value. Alpha equals 0.5 and the p-value equals 0 1959. Alpha p-value. Make a decision. Since alpha p-value, do not reject HO. Conclusion. At a 5% level of significance from the data, there is insufficient evidence to conclude that the distribution of voter preferences was not the same before and after the earthquake. Try it 11. 9. Ivy League schools receive many applications, but only some can be accepted. At the schools listed in Table 11, 22, two types of applications are accepted: regular and early decision. Application type: accepted Brown, Columbia, Cornell, Dartmouth, Penn, Yale. Regular 2, 115 1, 792 5, 306 1, 734 2, 685 1. 245. Early decision 577 627 1. 228 444 1. 195 761. Table 11. 22. We want to know if the number of regular applications accepted follows the same distribution as the number of early applications accepted. State the null and alternative hypotheses, the degrees of freedom and the test statistic. Sketch the graph of the p-value, and draw a conclusion about the test of homogeneity. You have seen the Chi-2 test statistic used in 3 different circumstances. The following bulleted list is a summary that will help you decide which Chi-2 test is the appropriate one to use. Goodness of fit. Use the goodness of fit test to decide whether a population with an unknown distribution fits a known distribution. In this case, there will be a single qualitative survey question or a single outcome of an experiment from a single population. Goodness of fit is typically used to see if the population is uniform. All outcomes occur with equal frequency. The population is normal, or the population is the same as another population with a known distribution. The null and alternative hypotheses are H0, the population fits the given distribution. The population does not fit the given distribution. Independence. Use the test for independence to decide whether two variables' factors are independent or dependent. In this case, there will be 2 qualitative survey questions or experiments, and a contingency table will be constructed. The goal is to see if the 2 variables are unrelated independent or related dependent. The null and alternative hypotheses are H0, the 2 variables' factors are independent. The 2 variables' factors are dependent. Homogeneity. Use the test for homogeneity to decide if 2 populations with unknown distributions have the same distribution as each other. In this case, there will be a single qualitative survey question or experiment given to 2 different populations. The null and alternative hypotheses are H0. The 2 populations follow the same distribution. The 2 populations have different distributions. A test of a single variance assumes that the underlying distribution is normal. The null and alternative hypotheses are stated in terms of the population variance, or population standard deviation. The test statistic is letter 1D45B-1, letter 1D460 to letter 1D70E2, where n equals the total number of data, S2 equals sample variance, sigma 2 equals population variance. You may think of S as the random variable in this test. The number of degrees of freedom is df equals n1. A test of a single variance may be right-tailed, left-tailed, or two-tailed. Example 11. 10 will show you how to set up the null and alternative hypotheses. The null and alternative hypotheses contain statements about the population variance. Example 11. 10. Problem. Math instructors are not only interested in how their students do on exams, on average, but how the exam scores vary. To many instructors, the variance, or standard deviation, may be more important than the average. Suppose a math instructor believes that the standard deviation for his final exam is 5 points. One of his best students thinks otherwise. The student claims that the standard deviation is more than 5 points. If the student were to conduct a hypothesis test, what would the null and alternative hypotheses be? Solution. Even though we are given the population standard deviation, we can set up the test using the population variance as follows. H0, sigma 2 equals 52. Sigma 2 52. Try it 11. 10. A scuba instructor wants to record the collective depths each of his students dive during their checkout. He is interested in how the depths vary, even though everyone should have been at the same depth. He believes the standard deviation is 3 feet. His assistant thinks the standard deviation is less than 3 feet. If the instructor were to conduct a test, what would the null and alternative hypotheses be? Example 11. 11. Problem. With individual lines at its various windows, a post office finds that the standard deviation for normally distributed waiting times for customers on Friday afternoon is 72 minutes. The post office experiments with a single main waiting line and finds that for a random sample of 25 customers, the waiting times for customers have a standard deviation of 35 minutes. With a significance level of 5%, test the claim that a single line causes lower variation among waiting times, shorter waiting times for customers. Solution. Since the claim is that a single line causes less variation, this is a test of a single variance. The parameter is the population variance, sigma 2, or the population standard deviation, sigma. Random variable. The sample standard deviation, S, is the random variable. Let S equals standard deviation for the waiting times. H0, sigma 2 equals 722. Ha sigma 2, 722. The word less tells you this is a left-tailed test. Distribution for the test. Letter 1 D712, 224. Where N equals the number of customers sampled. DF equals N, 1 equals 25, 1 equals 24. Calculate the test statistic. Letter 1 D7122 equals letter 1 D45B minus 1, letter 1 D460 to letter 1 D70E2 equals 25 minus 1, 3. 5, 27. 22 equals 5. 67. Where N equals 25, S equals 35, and sigma equals 72. Graph. This is a non-symmetrical chi-square curve with values of 0 and 567 labeled on the horizontal axis. The point 567 lies to the left of the peak of the curve. A vertical upward line extends from 567 to the curve, and the region to the left of this line is shaded. The shaded area is equal to the p-value. Figure 11, 8. Probability statement. P-value equals P chi 2 567 equals 0, 42. Compare alpha and the p-value. Alpha equals 0.5. P-value equals 0.42. Alpha p-value. Make a decision. Since alpha p-value, reject H0. This means that you reject sigma 2 equals 722. In other words, you do not think the variation in waiting times is 72 minutes. You think the variation in waiting times is less. Conclusion. At a 5% level of significance from the data, there is sufficient evidence to conclude that a single line causes a lower variation among the waiting times, or with a single line, the customer waiting times vary less than 2 minutes. Using the T83, 83 plus 84, 84 plus calculator. In second DISTR, use 7, chi to CDF. The syntax is lower upper DF for the parameter list, for example 11. 11 chi to CDF, minus 1 E99.5, 6724. The p-value equals 0.42, try it 11. 11. The FCC conducts broadband speed tests to measure how much data per second passes between a consumer's computer and the internet. At a certain point in time, the standard deviation of internet speeds across internet service providers, ISPs, was 2%. Suppose a sample of 15 ISPs is taken, and the standard deviation is 13. 2. An analyst claims that the standard deviation of speeds is more than what was reported. State the null and alternative hypotheses, compute the degrees of freedom, the test statistic, sketch the graph of the p-value, and draw a conclusion. Test at the 1% significance level. Stats Lab. Lab 1. Chi-square goodness of fit. Class time, names, student learning outcome. The student will evaluate data collected to determine if they fit either the uniform or exponential distributions. Collect the data. Go to your local supermarket. Ask 30 people as they leave for the total amount on their grocery receipts. Or ask 3 cashiers for the last 10 amounts. Be sure to include the express lane if it is open. Note, you may need to combine 2 categories so that each cell has an expected value of at least 5. Record the values. Table 11, 23. Construct a histogram of the data. Make 5 to 6 intervals. Sketch the graph using a ruler and pencil. Scale the axes. Blank graph with relative frequency on vertical. Figure 11, 9. Calculate the following. Letter 1D465 equals. S equals. S2 equals. Uniform distribution. Test to see if grocery receipts follow the uniform distribution. Using your lowest and highest values, XU. Divide the distribution into fifths. Calculate the following. Lowest value equals. 20th percentile equals. 40th percentile equals. 60th percentile equals. 80th percentile equals. Highest value equals. For each fifth, count the observed number of receipts and record it. Then determine the expected number of receipts and record that. Fifth observed expected. First, second, third, fourth, fifth. Table 11, 24. H0. What distribution should you use for a hypothesis test? Why did you choose this distribution? Calculate the test statistic. Find the p-value. Sketch a graph of the situation. Label and scale the x-axis. Shade the area corresponding to the p-value. Blank graph with vertical and horizontal axes. Figure 11, 10. State your decision. State your conclusion in a complete sentence. Exponential distribution. Test to see if grocery receipts follow the exponential distribution with decay parameter 1 letter 1D465. Using 1 letter 1D465 as the decay parameter xexp, calculate the following. Lowest value equals. First quartile equals. 37th percentile equals. Median equals. 63rd percentile equals. Third quartile equals. Highest value equals. For each cell, count the observed number of receipts and record it. Then determine the expected number of receipts and record that. Cell observed expected. First, second, third, fourth, fifth, sixth. Table 11, 25. H0. What distribution should you use for a hypothesis test? Why did you choose this distribution? Calculate the test statistic. Find the p-value. Sketch a graph of the situation. Label and scale the x-axis. Shade the area corresponding to the p-value. Blank graph with vertical and horizontal axes. Figure 11, 11. State your decision. State your conclusion in a complete sentence. Discussion questions. Did your data fit either distribution? If so, which? In general, do you think it's likely that data could fit more than one distribution? In complete sentences, explain why or why not. Stats Lab. Lab 2, chi-square test of independence. Class time names. Student learning outcome. The student will evaluate if there is a significant relationship between favorite type of snack and gender. Collect the data. Using your class as a sample, complete the following chart. Ask each other what your favorite snack is, then total the results. Note you may need to combine 2 food categories so that each cell has an expected value of at least 5. Sweets, candy, and baked goods, ice cream, chips, and pretzels, fruits and vegetables total. Men, women, total. Table 11, 26 favorite type of snack. Looking at Table 11, 26, does it appear to you that there is a dependence between gender and favorite type of snack food? Why or why not? Hypothesis test. Conduct a hypothesis test to determine if the factors are independent. H0. What distribution should you use for a hypothesis test? Why did you choose this distribution? Calculate the test statistic. Find the p-value. Sketch a graph of the situation. Label and scale the x-axis. Shade the area corresponding to the p-value. Blank graph with vertical and horizontal axes. Figure 11, 12. State your decision. State your conclusion in a complete sentence. Discussion questions. Is the conclusion of your study the same as or different from your answer to question 2 under collect the data? Why do you think that occurred?